Good morning, everyone. Thanks for joining us. We're going to be just allowing a couple more people to get signed on here, and we'll be getting started in just a moment. Okay, let's go ahead and get started. Again, good morning. Thank you so much for joining us. We've got an exciting webinar this morning for you. We've got collaborative robot welding. And this entire webinar is being presented to you live. In addition, we'll have live Q&A. So please get your questions ready. We encourage you to jump in at the end of the presentation. But first up, we have FPE Automation's Jomy Vadakumpadam and Josh Pawley from Vectis Automation speaking to you. And so we'll begin with Jomy. Jomy, I'll turn over to you.
Yeah, great. Thank you, Sandia, and thank you everyone who's attending remotely. Appreciate your time this morning, and this is the latest addition to our FPE Toolbox webinars, specific solutions surrounding our product representation here at FPE Automation. So this is the latest, targeting specifically not just collaborative robots, as you probably have been exposed to, but specifically a vertical market around there, which is collaborative welding. So for those that don't know me, my name is Jomy Vadakumpadam. I'm the manager of the automation controls group here at FPE Automation. I manage the application engineering team, who you've probably worked with in some capacity, from pre-sales, sizing, design, down to post-sales support, programming, implementation, etc. So again, thank you for your time. I wanted to talk a little bit about FPE, but the bulk of this presentation is going to be definitely turned over to Josh over at Vectis Automation. So a little bit about FPE, for those that don't know us. We became a universal robots distributor in 2015, and since then we've experienced tremendous growth with that product line and the solutions around that. So that's catapulted us to be a top 5 distributor in North America for universal robots. Since then, in our territory of Illinois, Missouri, and Iowa, we've deployed a little bit over 350 robots. And supporting that fleet of robots is myself and then my team behind me, which have extensive knowledge in implementing those robots. That's 8 application engineers with varying degrees of involvement. 2 of them are full-time universal robot product managers, and then further support behind that as it comes to application-specific things like vision guidance, bin picking, things like that. Highlighting the robot, since that's one piece of the solution, we wanted to really capitalize and show you guys our partnership with our integration partners, because the robot is a main component of an automation solution, but it's certainly not the only piece. And we really value our integration partners, Vectis being one of them, that can provide our customers and then a full turnkey solution. Beyond the integration partner network, we do have partnerships with over a dozen UR Plus certified vendors. So that could range in the form of a specialized gripper, vision system, flexible feeding, 7th axis, things like that. And we are proud. I wish we can have you all into our offices between Chicago and St. Louis, but given the situation today, I thought it would be good to give you guys a virtual tour of our building. This will just take about 2 to 3 minutes if you don't mind. I'd appreciate it. But at the end of the day, we sincerely appreciate your business, your time, and any opportunities you've given us to help with your automation projects. So if you're thinking robots, we hope you can think of FPE Automation. And with that, I'll play this video.
Hi, my name is Sandia, and I'm here to take you on a virtual tour of FPE Automation's authorized technology and training facilities. FPE Automation has 2 technology and training facility locations. One is in the greater Chicagoland area, located in Elk Grove Village near Chicago's O'Hare Airport. The other is in Sunset Hills, Missouri, and serves the greater St. Louis region. When they opened, the 2 facilities were among the first of their kind in the world. Today, they feature capabilities and product demos not available anywhere else in the region. Here at FPE, we feel that the education of our customers and their employees is paramount in the successful implementation of in-plant automation, in particular, collaborative robots, vision, and motion control. Each location features a spacious area with a universal robot, collaborative robot, a vision camera, and a conveyor at every workstation for hands-on training. Interactive classes take place on a regular basis. FPE training is factory certified and taught by field experienced instructors. We offer authorized Universal Robots core training, and it doesn't end there. You can learn about machine vision, safety, and numerous other industry hot topics at FPE. In addition to training, both facilities feature a state-of-the-art technology center. There we demo and test today's cutting-edge automation, like vision systems, the latest industrial robotics, 3D bin picking, AI, and more. Visitors can see the products at work in person, or we can schedule an online virtual meeting. Whether you need a proof of concept or just want to check out the technology, we can make that happen. Tech support and service are a particular strength of ours. That's because we have a team of award-winning application specialists to assist you. They're among the best in the business, and they're here to help. All of this is designed to increase your comfort level and success of the automation implementation at your facility. The goal is to increase your company's efficiency and profitability through smart automation that makes sense. All of us at FPE Automation would like to say thank you to our customers. FPE opened its doors in 1963. It is through your continued loyalty through the years that we were able to make the investment in these two facilities. That allows us in turn to better serve you. For that, we are extremely grateful. Thank you for taking this virtual tour of our technology and training centers with us today. We look forward to working with you soon.
Okay, great. So appreciate you guys sitting through that with us. And I'd like to take a moment to highlight, there's a lot of technology there, and I understand with the given the situation in the environment today, we can't always visit you or should bring our products, but you saw a lot of technology on display. So please leverage us. We have engineers on the staff that can help you with proof of concepts, evaluations. If you need to come in, we have this set up where we can socially distance responsibly and still go through the technology with you. So please don't be shy about any of those requests. And without further ado, I'd like to hand this over to Josh over at Vectis. This is a very interesting webinar for me because we don't get to do live demos all the time, but this is a really up and coming, exciting technology that Vectis has brought out to the market last year, starting with FabTech, formerly with Universal Robots. So Josh is going to show what their system can do, and it's also neat because he's going to allow you guys to see the teach pendant as if you were right in front of it. So without further ado, I'll hand the screen over to Josh.
Awesome. Thanks, Jomy. And let me know if you guys can't hear me. I'm sharing my screen right now.
We're good.
And should have the presentation up.
Yes, sir.
Awesome. Well, I'm going to echo Jomy's comments of thank everybody for their time and for listening in here today. As Jomy mentioned, my name is Josh Pawley. I lead up our business development activities, and I was a founding partner of Vectis as well. I look forward to chatting with you today about how welding applications with easy to use and safe collaborative robots can help boost your productivity. So the outline of kind of what we're going to talk about, I'm going to show a brief product video that gives an overview of what the system does, talk a little bit about Vectis Automation, go into some of the details of the product, talk about some of the key guidelines that makes a welding application and weldment good for automation or bad for automation. Not all applications are created equal, and so we want to make sure, as Jomy mentioned and as FPE does as well, that it's a solution, right? It's not just the product, it's a solution for an application. And then lastly, we're going to finish up with a live demo of the programming interface, the Vectis programming interface, and we'll run an actual weld as well. So I'll let this video go. It might be a little choppy over the Zoom, but it is also available on our website and our YouTube channel.
Josh, the computer audio is not coming through, so if there's anything you want to speak about, please do so.
Gotcha, thanks. And we'll just kind of let this play through. You guys can kind of get a feel for it, and then we'll go through this live as well, so I can speak to it a little more then. So, but just wanted to give a brief overview to begin with. All right. So wanted to chat real quick on Vectis. As Jomy mentioned, you know, we're a certified systems integrator for Universal Robots, and we partner with FPE to provide solutions, particularly in the welding space. So we are a team of engineers. We've got about 75 years of combined experience doing robotic welding with traditional robots, and we've kind of carried that experience, the good, the bad, and the ugly, with us into the collaborative robot realm to help make automated welding easier, lower cost, and lower risk. We're based out in Fort Collins, Colorado, about an hour north of Denver. And like I mentioned, we're entirely focused on providing a cobot welding tool that manufacturers can use to boost weld shop productivity for lower cost, lower risk, and easier than ever before. And the reason why is that the American Welding Society is estimating a shortage of 400,000 welders in the U.S. by 2025. And we really do believe that a collaborative man plus machine is going to help fill that gap. I'm sure I'm preaching to the choir for some of y'all that have trouble finding welders or keeping welders. We hear that all the time. And so we're trying to make welding automation simpler to help fill that gap. So a bit about our product and what we do. We provide a system product that you see here and that you'll see on our live demo as well. And some of the key features of that is that it's portable. So there's no anchoring required, and you can bring the cobot to the work. And a lot of our customers have said that, you know, the fact that they can move that around their shop, bring it to existing fixtures, and just rearrange their shop as needed for whatever projects coming through is a huge value point, as opposed to traditional robot work cells that are anchored to the ground and kind of are a monument in a facility, if you will. So there's a portability aspect of it. It's versatile, so you can weld on the cart, or you can also weld off of the cart on an existing fixture. And we have customers that butt the cart up to a modular fixture table or an existing fixture that maybe handles a large part. And so it's very flexible and versatile in that sense of where you can program and what kind of things you can program. The nominal reach of the robot is 51 inches, and we'll kind of get into that later of what reachability is for a welding robot. And then there's also a free drive button that you see here and that you'll see me using in the live demo that allows you to just push and pull the robot around and teach via that method, which really simplifies the teaching and makes it much more intuitive. And it's flexible, so the entire footprint of the system with the spool on the back is 3 feet wide by 6 feet deep. And the 3-phase or 480 high voltage is not required. It can run off of 480, but the robot runs off 120 volt wall outlet, and the welder can run off of anything between 208 and 575 volts, including 240 single phase. So there's a little bit of versatility in where you can plug the system in, or for folks that don't have access to 3-phase, there's that option as well. And here are just a few pictures of some of the applications that our customers have done. I think this one on the bottom left here is a really interesting picture of a customer that chose to butt the cart up to a table to handle a large part, right? So kind of showing that flexibility of the portability of the cart and the slim footprint, but also you can handle larger parts or existing fixtures by doing that. And then you just see some other applications here. Very common way that customers use the system on the cart for small parts is by actually mounting up an existing manual jig, like you see here. This customer was doing these manually, but was able to datum that jig on the table and then run those on the robot at a productivity increase of about triple versus manual only. And then you just see some other applications here that we've done, thin gauge, thicker materials, things like that. A few more, you see outside corners can make a great robot application. We've got some customers doing outside corners that have essentially eliminated grinding from those. They come off the cobot and go straight to paint or blast. And you just see some more applications here. Multi-pass and thick welds are possible as well. You can kind of see a penetration profile of that there. That was with 045 wire. And lastly, just a few more. Some of these are leveraging some of our premium features. So we've got a pattern tool and a tack tool that I'll kind of show some pictures of later that was helping to do that application. This customer in particular, there's like 130 tacks on that part that, some welder has to go do now. And it's a pretty mind-numbing process. So the fact that they could be able to offload that to a cobot was really interesting to them. So as I mentioned, our real focus is making automation as simple to use as possible. And our customers report that they're mostly set up and welding on their own within hours of the system arriving. And so we've really kind of changed the paradigm there, in that you don't have to have our tech come on site for thousands of dollars. You don't have to fly out to us for training. We know that's painful for some folks. That, hey, it's really painful to lose, my operator or my programmer for a week or two to come out to training. So we've really just tried to simplify the system to where it's do it yourself. And our customers are mostly set up and welding within hours. I would say, most are in production within the first week, if not sooner. And that's really brought about by the programming interface that we've built, our Let's Weld Together software. So I'll show some screenshots here, and of course we'll see some more in the live demo as well. But we've built a graphical programming platform that reads very simply. So there's no coding. There are simple commands of, hey, I want to do an air move to here. I want to do a weld here. You've got some visual context to handle. How do I program a circular move, right? What's this via point? What's this weld through? What's this weld through? We provide some visual context to help the programmer right on the pendant decide how to program. We've built in all of our weld and weave parameters to the system. So you control travel speed, voltage, or trim if you're doing pulse, wire feed speed, crater fills, and then weaves as well. So we're able to weave in a inline whip fashion or a zigzag fashion or a stringer, of course, as well. And we'll show the zigzag today. And the system also comes with some baseline weld templates that are pre-programmed into the system, where you can say, hey, I want to pull up, I'm running 035 wire on mild steel, 1/4 inch fillet in pulse or spray. And we're going to use one of those templates today, actually. You kind of see what welds you'd get right out of the box. And then, as I mentioned, we're a big focus of ours is the software development and making it easier to use and providing tools that make programming much easier. So some of those, just some examples, are a pattern tool that you see here, this screenshot here, where you've got a start of the pattern, end of the pattern, and a number of iterations. So you can do that for a batch of parts or for a weld that's common on a single part. We've also got a stitch weld functionality that you see an example of here, tacking, touch sensing, and that's something that we're continually investing and developing is additional software features based on customer needs. And so in addition to ease of use, it's about the cost as well. And so, you know, our costs, we've made it an all-in price that includes shipping. Again, since it's got a DIY nature, it's not, here's the base system price plus all these options plus training. It's really an all-in system price that is very affordable. And most of our customers see a payback of 2 years or less, and they're seeing boosts in productivity on a batch of parts in the double to triple realm is the most common rule of thumb. The system does ship fully integrated, so you see some pictures of systems shipping out here. Again, most folks are set up within a few hours, and we do offer a 30-day return policy as a safety net as well. Lead time is typically 4 weeks. We have options for expediting as well. We do offer a financing program with a third-party partner with very attractive interest rates. And then we also do operate a shorter term rental or rent to own program with a limited fleet if that's interesting to some of y'all. And so for firm pricing and a proposal, feel free to reach out to us. We also do go through a application evaluation process. So we'll kind of talk a little bit more about that in a bit, but it's key to us that, you know, that we're helping on the application front of, hey, this is going to work, or this isn't going to work, or you're going to need to be mindful of these factors as well. So in addition to a pricing, we can help with an application evaluation. And these are just some customer testimonials. You know, one of our customers up in Montana, they told us that they were cutting shrink wrap in the morning and in production by the afternoon. Similar testimonial from an agricultural company near us. They started contributing the day it was delivered. This company had looked at traditional robotic welding in the past, but it hadn't made sense for them. Another job shop, a small to medium-sized job shop, also looked at traditional robotic welding, but primarily for them, it was the footprint that didn't make sense in their shop. And so they were able to get going very quickly and run even small batches of parts. I think the smallest batch of parts that they've run that has generated a strong ROI for them was 12 parts actually. And then one of our customers out in Illinois that we partner with FPE with, at Ludlow Manufacturing is running 3/16 fillets at 33 inches a minute, and they're seeing productivity gains in that triple range as well. And that's a customer with traditional robots that found value in a cobot to supplement that and help with some of the smaller parts or smaller batches and even the proof of concepts. So I kind of want to dive into some of the general guidelines of what makes an application a good fit for automation. And again, we're happy to help with specific application evaluations. If you can share pictures and drawings, we'll provide some contact info and you can reach out to us as well. And real quick, just hitting on, if it's done right, what are some of the benefits you can expect from automation? I'm sure you're familiar with a lot of these. You know, you're softening the blow of the skilled welder shortage, you're improving quality and consistency, improving safety, and reducing operator fatigue. You're lowering manufacturing costs in the weld department, but also in the post-weld operation. So a lot of our customers have reported, you know, we're either reducing or completely eliminating post-weld grinding, which is a non-value add process for them. And so it's going straight to bead blast or paint. And so you save a lot of time, not just in the weld shop, but also on the back end as well. And more business potential. So there's increased capacity in the weld shop, and you're typically able to reduce lead times and costs as well and be more competitive. But to do it right, there has to be a few things that are kept in line. And so we really boil it down to three things that we've seen through our 75 years of experience that help automation go right. And number one is the consistency is key. Number two is start with the low-hanging fruit. And number three, making sure you've got the right champion on the system. So we'll go into each one of these. So consistency is king. And the key there and why the darts aren't in the bullseye is that repeatability is more important than absolute accuracy. So all that matters is that from the part that you program on, that the next part and the part after that and the batch after that, they look much the same, right? And there's two aspects of consistency. There's a dimensional placement, so where is the actual joint in space? And then there's the cross-section of the weld joint as well. And both are important. I would say the weld joint cross-section is even more important because it's based on how the weld's going to look. So those are just two things to keep in mind. A cobot or a traditional robot is not going to inherently know if a part has moved or the cross-section of a weld has changed. And the best way, honestly, to manage inconsistencies is to improve upstream processes and fixturing. And I think one of the things that has really enabled more welding in more shops has been the advent of more lasers and CNC brakes and just computer-controlled parts in general, right? And so some green lights here, no gaps or having consistently small gaps. And I'll show some examples of that that kind of go in further into detail. Laser or CNC plasma tables are excellent. CNC bent parts are excellent. Pre-tacked is typically a plus if it's fixtured well, but we do have plenty of customers that are welding untacked parts as well and kind of hold and locate jig. Some red flags typically are going to be if there's any manual cutting. If you see parts being shoved or hammered or beaten into place, it's typically a red flag. If you're doing a lot of pre-weld grinding or manual joint prep, that's really going to change the cross-section of that joint, right? So that's one thing to look out for. And then open root or full penetration welds, whether it's a cobot welder or a traditional robot welder, those have been a pretty elusive application and difficult to do for a variety of reasons. One thing that is possible with that is doing a manual root and then having the robots fill to the cap as well. So then starting with the low-hanging fruit is the second thing. One of my colleagues had this great quote: if a person looks like a robot all day, it's probably ripe for automation. And we've seen there's a temptation typically to automate the largest part or the most complex fabrication that comes through the shop because it's such a labor drain whenever one of those goes through. And we can understand that. And it's not to say those parts aren't possible, but what we've seen is that the most effective deployment of automation is to start with those small, simple pallets of parts. And that's what I always recommend is, look to your manual weld stations. Where do you see the pallets of parts coming out of there, the little dinky brackets or sub-assemblies, things like that, right? And then the idea being that let automation take care of the monotonous and repetitive and shift your, skilled welders that are already in short supply to the weldments requiring skill, the larger pieces and more complex assemblies. So some green lights there. MIG fillets, bevels, and grooves. Steel or stainless. Aluminum is trickier, but it can be possible depending on the alloy and thickness. It's just something we'd like to take a little closer look at with you. If you have a part that's relatively open for torch access, where you're not got a lot of blocking features for the torch to get to, planar welds that require no or minimal repositioning, but we've had some customers do some really clever work with multiple fixture nests and staging or manual headstock tailstocks that are really low cost and simple to use. And then a high arc time relative to the size and the number of welds as well can really be helpful. And lastly, I'll show some pictures of this coming up, but we do not have a TIG package right now, and there's some complexities with TIG on automation that make that that have caused that. But we have seen a number of TIG applications that could potentially be done with cobot MIG because you have more consistency and more control. And man, you talk about a increase in productivity going from manual TIG to cobot MIG. We've seen them in the 10 to 20x range if the application is a fit for it. So that's something really interesting. So don't rule out TIG. Let's talk about it. And lastly, the last key to success is having the right champion. And what we've seen through our experience is that someone who's eager and wants to take ownership of the project and the system is going to be more important than any level of technical knowledge. We've seen that technical knowledge can be learned, and we've got a lot of facilities from our YouTube instructional videos to our user guide where folks have been able to pick up a pendant and get going right away if they are excited and eager to make it work. And those champions come from all backgrounds. We've seen them as the owners themselves, the owner's son or daughter, engineers, shop foremen, machine operators and welders as well. And they don't have to be a welder. There's ways to learn welding science and welding knowledge, just as there's ways to learn the programming as well. We've seen any one of those people become a successful cobot champion if they're eager and want to take ownership. So just want to show a few pictures before we get to our live demo here, kind of the cobot MIG versus manual TIG. So you see some manual TIG pictures on the right, and then you see some of the welds that our cobot has laid down. And you can kind of see how, hey, there's potentially there are cases where current manual TIG operations could be done with MIG as well. So if you're doing some manual TIG and you want to automate it, let's talk about it. Let's see if it might be an option for cobot MIG. Some slam dunk applications you see here. Fillets tend to be a really great application. Anything usually thicker than 16 gauge or thicker is kind of the sweet spot for automation. And so you heard me mention reachability. So you see here when I talk about the 51-inch cobot reach, that's kind of the industry standard, and any robot's reach is measured from axis 1, this base here, to the wrist flange, right? So that's where that 51 inches come from, and what you'll see in industry when a specific robot's talked about. And then our weld torch and our bracket at about 17 inches from the flange to the weld wire itself. But what's interesting is that 17 inches for welding can actually help or hurt you. So the pictures on the right that you see here, the torch is actually helping because we're gaining the additional 17 inches because we're reaching fillets and bevels, right? Now, if you're welding a part like this customer that's doing some vertical downs on square tubing, they're very possible, as you can kind of see here. But the thing is, you're going to use more reach because you actually have to reach back towards the robot, right? And so there's some adjustability in the torch to help with that, but that's just one thing when we do our application evaluations together with you that we like to look at and make sure that the robot's going to be able to reach, or that we've got an ability to do a multi-stage fixture or something like that to handle the reach. So one of the really nice things about the cobot and its built-in safety is that it gets you multi-zone and multi-part in a very flexible manner. So traditional robot welding cells can do what's called dual zone. You can buy a dual zone system where I've got a zone of a specific size that I can work in here, and my robot's working there while my operator's loading, unloading in the other, and they switch back and forth. The issue with that is that it's not flexible because that zone, because that robot does not have built-in safety, that zone is very specifically defined. With the built-in safety of the cobot, it's entirely flexible where you set your zones and how you set those up, right? So we've got a customer that you can see here where they've got a part on either side of the robot, and they're, while the robot's working on this one, the operator's loading, unloading over here, and they've built their own arc flash protection between them for the operator to be protected there. And then, you've got another customer over here that, hey, I'm going to have one of my parts in one stage fixtured like this on the cart, and then the other is going to be up against an existing fixture over here, and the robot operator can switch back and forth between those. And then you've got this customer, this is that Montana customer actually, where, hey, I'm just going to run a batch of 8 parts right here and leverage the pattern tool in our software to do so. So then the last thing we'll talk about before the live demo is the importance of gaps. So as you heard me mention, the key is having no gaps or consistently small gaps. So on the left here, this is 16 gauge material. You can, if the joint looks like this every time, it can definitely be welded. What the issue is on a different part, you have this gap on fairly thin material, but then you look at the next corner and it's actually closed, right? Then you look at the next corner, it's an even bigger gap. And the problem there is that the robot can't adapt weld parameters to do a different fill of that cross section, right? So gaps are possible, but they need to be consistent and small relative to the material thickness. And that's one of the things that we're happy to help with and provide an evaluation on your specific parts for. And then here's the last example of, this is 16 gauge miter material, pretty tough application that when the gap is tight, it looks beautiful. But if that gap opens up, this weld will be just blown through, right? So that's kind of what you'll see when you have inconsistent gaps. And last thing I want to finish on before we go to our live demo is the fact that gaps can be done successfully. So you see here, this is a pretty large gap. I hit the button. Sorry about that. Pretty large gap, but it was very, very consistent. Laser cut, CNC bent, looked the same every time. You can develop a weld parameter set that's going to fill that properly every time. This customer, I spoke with them yesterday. They're actually running triple the production on the cobots for this type of part than they were just manually. So they were running 280 parts a day on the robot, and they never got above 90 with just manual for one person. So a good example of consistent parts, even if it's maybe a non-traditional gap, can be done if they're consistent. So with that, we'll move on to the live portion of this demo here. Let me get set up really quick here.
Yeah, well, if you guys don't mind while Josh is getting set up, to his point, please, use Vectis to leverage the welding expertise. But when you're getting that champion or internal person that's kind of taking ownership of the system, please use FPE to help fill in any type of technical knowledge on the robot side. We typically do training every 6 weeks here at the Chicago location, and then 6 to 8 weeks at the St. Louis location. So you don't have to be a welding expert, you don't have to be a robotics expert. We can help fill in the robotics side, and then Josh and the Vectis team can help fill in the welding side as well as the entire system. So we will, between us two, we can round out that knowledge for you pretty well.
Awesome. Jomy, can you see my webcam, the camera shaft in my head, and the DNC of the pendant?
I see both, yep.
Perfect. All right. Well, so here's our system here. This is our standard base system with an air-cooled package that you're seeing here. So again, it's on the mobile cart that you see. Got the Miller welder, the robot brain there, and an op panel, wire feeder on the back. Everything's electrically isolated. And then our air-cooled torch there as well. And then lastly, or just to show this is our water-cooled version, where we've got a water-cooled 400-amp torch with a water cooler on the back there as well, still mobile and portable. So we're going to be using the air-cooled system. That's our most common system, but we're going to do an air-cooled weld and show you the programming on this. So when you first load up, or when you first boot up the system, you're going to see this screen here that you see on the right of my screen. And so what I'm going to do is I'm going to hit New Program, okay? And then I'm going to save that program to begin with, as you can name it whatever you want. A lot of customers just name it their part number. So we're going to name it FPE Demo, and that's going to allow us to keep this. So again, as I mentioned in the presentation, we keep it simple. We've got four instructions that we can use. We can make an air move, we can make a pattern, we can do a tack weld, or we can do a full weld. And then you've got expanded options in each one of those. So we're going to start our program with an air move. And an air move is really like a move to a home position or somewhere out of the way so that the operator can load, unload the system, right? And so this is going to work fine for a representative air move. And what you saw me doing there, this is that free drive button that allows me to push and pull the robot in any given direction. When I let go of that, the robot stays firm, right? So it is releasing its brakes, but it's actually keeping the servo motors on and just watching them force and torque and matching that with however I push or pull it. So that's going to work for our air move location right here. So I've hit the air move button. That's added it to my program tree, right? And I'm just going to hit update waypoint. And what that does is that teaches the current position of the robot as that air move point, okay? So next I want to make a weld along my T-plate here. So I'm going to hit the weld button. And when you create the weld, it always starts with a full template. And the template includes an approach point, a start point of the weld that we'll teach, an end point of the weld that we'll teach, and a depart point, right? And that's the simplest form of a weld, just a single line. If we need to get more complex, if we've got, let's say, a compound path like you see here on that visual context, where we've got, a point where we need to move along there, we can add a through point to our weld. We can add any number of through points. And we can also make the through points circle points, right? So we can actually do a number of circle points to get a result like you see there. or also over there. So this is a really interesting application because this was a set of multiple through moves. We had a linear through move, we did a linear circular moves, and ended with a linear move to get that full base piece done in one weld. And then we did the verticals to finish the gusset to pipe. So, but for this example, we're just going to be running a simple start and an end linear weld. So I'm going to delete that weld through. So, and forgive me guys, my head cam strap just came off. So I'm working with that. Give me one sec here. See if I can get that back on. Make that work. There we go. So now that we've got our weld template set, anything that's yellow in my program tree needs an input. So my weld start, I'm going to free drive down to my weld start point here and just place it there in our joint, right? And for most applications, I'm just going to run about a 10-degree push angle and then a 40 or 45-degree work angle. So that looks pretty good right there, okay? So now that I'm in the position that I'd like to be, I'm just going to hit update waypoint, which teaches this current position as my weld start point. Now the default for a weld approach is that we're programming it automatically based off where the start point is, just saving some time there. If you needed to, you could make a custom approach or depart one as well. But the approach for this example is just going to come out in the direction of the torch. And then we'll teach it our weld endpoint. And you can use the free drive to move to the endpoint. The other way that you can jog the robot is actually with XYZ handlebars as well. So I'm going to do that and move out here a little bit and then come along my X direction there to the end. And what's nice about that is it allows you to keep the same torch angles from the start to the end. And then if I need more fine adjustments, I can just throttle my speed down a little bit and get it right where I need it to, right in that joint. Right there. And then so once I've got that in the correct position, I'll just hit OK. And that will now save my endpoint right there. And so when I look at my tree here, I've got all of my program points made because there are no more yellow nodes. So the last thing to do before we weld is actually select our weld process parameters. So we go to our weld start, move to our process tab, and there are a number of pre-programmed welds that we have here as well. So I'm going to use our 035 steel. We're running 035 wire, 1/4 inch horizontal fillet, and we're going to be doing a pulse weld here. So we see the data that's held in that template. I can't change the template here because that's allowing you to control what weld parameters are done with if you have specific weld parameter sets that you'd like your program to use. Or alternatively, I can also use unique data and I can make changes to that common data for this specific weld right here. So I could say, you know, let's bump up our travel speed or whatnot, but we'll just use the standard template for now. So I'm gonna go back to use common data. So now with our program path point set and our weld parameter set, I'm going to make sure my weld is blocked. So that's this little icon here. When that's selected and you've got the sparks there, that's going to be a live weld the next time it's run. And if it's not, it's going to be a dry run. So we've got a dry run set. I'm now going to hit the play from beginning. And we'll do a dry run of this weld here. So you can see there, we've set our trim value to 52.8 and our wire feed to 550 inches a minute. And that's the cobot, again, controlling all that. And you see the weave action in the joint there as well. All right. So there's the program. So now all I'm going to do to get this started is hit the live weld button. So now I've got the sparks showing and it's going to throw some sparks. And we'll go ahead and weld this. And I'm going to look away with my arc flash protection, but I'll keep the camera on the system so you guys can see it weld. All right, fire in the hole. And there's that weld with the out-of-the-box parameters. So that kind of concludes everything that we had planned. And I think, Jomy, we can probably open it up to some Q&A now.
Yeah, no, that was great. Appreciate the fire in the hole heads up.
Okay.
Yeah, so we have been, we can open up questions to the Q&A. If anyone wants to ask a question live, Sandia can unmute you. Just raise your hand. There should be.
So yeah, you can actually ask in the Q&A or in the chat section, whatever you prefer. We did have one question come in during the presentation about whether the recording will be available, and the answer to that is yes. We'll be posting that on our YouTube channel shortly after the webinar. So if you need a copy of this later, we can absolutely get one to you. If you're having trouble finding it, by all means, just contact us and we'll shoot you a link. But anyway, I will give everyone a chance. I know it takes a moment to type your questions in.
Yeah, Josh,
on the line, Brian Connor, also from Universal Robots. So we have actually a team of 3 with Jomy and Josh to answer your questions. Jomy, were you about to say something? I see some questions coming in.
Yeah, I was just going to read the questions out loud. Randall is asked. Josh Randall is asking if the Vectis solution uses Miller products only.
Randall, let's get in touch. Let's shoot me an email, or we can grab your contact info. We are in process of developing support for other platforms as well. So let's get in touch about kind of what you're looking for in terms of a welder, and I think that we might be able to help.
And we do have another question that came in from Justin. Can the welder settings be changed from the UR pendant, or is it from the welder?
So everything's controlled via the UR pendant. So you're controlling voltage, wire feed speed, the welder settings via the cobot pendant.
Okay, and I think that we already answered this question. It looks like a similar question. Can the TIG settings be changed from the UR pendant, or if it has to be changed on the welder? So there we go. That's kind of what you just addressed, correct, Josh?
Yeah, I think so.
So anyway, keep your questions coming in. In the meantime, Brian, do you have anything you'd like to add?
I think everything's good on my side. I certainly appreciate everyone's time joining in. Again, as I mentioned, my name is Brian Connor. I'm with Universal Robots based here in the Chicagoland area. So, you know, I've talked with some of you guys already that are on the line, work very closely with Vectis and FPE. So feel free to reach out if you need anything.
Yeah, I'm putting up my contact info again. Again, reach out to FPE, Brian, or myself. We all work as a team to support you. So happy to help look at applications.
I don't see any additional questions coming in, so unless one pops up here, what I'd like the group to know is that you can contact Josh there at that email address on your screen, or we at FPE have a general email address. It is acd@fpeautomation.com, and that stands for Automation Controls Division, so ACD, and you can reach out to us there as well. We're all happy to help. If you think of something after today's presentation that you'd like to ask, please feel free to do so. With that, I don't see anything else coming in, so we'll go ahead and wish everyone a great day. Be well out there, stay safe. Actually, we did just have one last question come in. Ever mounted a cobot on a buggo? From Randall.
Not yet, with something that we've discussed as well. I think it's really application dependent when we're talking about mobile cobot welding solutions. So we have had some folks that make the cart, the standard cart itself, move along a track. So like these are one of those things, Randall, that let's get in touch and see if there might be a solution for you.
Yeah, we'll follow up.
Thanks so much. Okay, guys. Well,
Thank
again,
you.
thanks for attending and have a great day.
Yep. Thank you for your time.
Thanks, everyone.
Thank you, everyone.
Appreciate your time.
Bye.